So in today's lecture, we'll do section 5.1, the last topic for our course. So it's titled Right Triangle Trigonometry. So here we see Hipparchus of Nicaea. He is considered the father of trigonometry. So he lived around 180 BC or 190 BC until 120 BC, etc. Okay. So he is considered the father of trigonometry. And this trigonometry, okay, it came from the Greek words trigonon, which means triangles, and metron, which means measure. So basically trigonometry, according to these um, two words here, is a study of triangles and its measure. Okay. So this trigonometry here, it's actually a big area in mathematics, okay? But in this course, we will only consider right triangles. So we will study the parts of the right triangles, the measures of right triangles, and some of its applications, okay? Now, back in section 3.3, if I remember that correctly, section 3.3, we already had this formula. This is called the Pythagorean formula. So if we have a right triangle with legs length equal to A, the other one is B, and then the hypotenuse is equal to C, then this equation here holds. We have A squared plus B squared, that's equal to C squared. Okay, so in here we have these two legs of the right triangle, and then we call this longest side, okay, for the right triangle, the hypotenuse. Okay, now there are two more important parts in here, actually three more, but one is this guy, which is the 90-degree angle. The other two parts are actually this part here, the angle here, and the other one is the angle in here. Okay, so what we're going to do is to define new functions, okay, and they are called trigonometric functions, and these trigonometric functions will be defined in terms of a right triangle. Okay, so in here, suppose we take this angle here, the angle theta, okay? And therefore, if this is the angle theta, we will label this side here or this leg here, okay, adjacent side, okay? Adjacent because it is the one adjacent to the angle theta. And the other side, the other leg, which is the opposite of the angle theta in here, will be named opposite. And of course, the longest side in the right triangle, we will still call it the hypotenuse. Okay? So take note that the names opposite and adjacent, okay, they depend on the theta. Okay? If you choose your theta to be here, then this guy here will be adjacent and this guy here will be opposite. Okay? So take note, the adjacent here means it's the one adjacent to the angle. And the opposite is the one opposite to the angle. Okay? So with these names, we have the theta here, and then the opposite is the leg opposite to the angle theta. Adjacent is the leg adjacent to the theta, and the hypotenuse, of course. We define these 6 trigonometric functions in here. This is the symbol, sin theta, but this is read as sine theta. Okay? And this guy here, the value of the sine of theta, this is equal to opposite over the hypotenuse. So you get the length of this leg and then divide it by the hypotenuse. And that will be the sine of theta. Okay, so let me write here this guy here. So sine of theta. Okay, for this guy, this is cos theta, and the full name of this is cosine of theta. So cosine of theta, and this is equal to the adjacent side divided by the hypotenuse. If this is your theta, this is the adjacent, so the value of cosine theta will be the length of this leg divided by the length of the hypotenuse. Okay? And then the third here, it's labeled tan theta, but the longer name, it's tangent. Okay? So this guy here, it's the tangent of theta. And in symbol, it's just tan theta. And this is now equal to opposite over the adjacent. Okay? So this is your theta, this is the opposite, and this is the adjacent. So the tangent of theta, this is equal to opposite over adjacent. Okay? If we look at this, you have opposite over adjacent. If we use only the two trigonometric functions here, the sine theta and the cosine theta, okay, the tangent theta is also equal to sine theta divided by cosine theta. Okay? So the value of tangent theta, this is also equal to the value of sine theta divided by the value of cosine theta. Okay? Now, these three guys here and their values, okay, collectively, they are known as Sohcahtoa. Okay? So the three values here, sine theta, cosine theta, and tangent theta, they are known as Sohcahtoa. This is a famous name. Okay? And why is this important, at least for students? This gives mnemonics. Your sine theta, it's equal to the opposite over the hypotenuse. So look at this. It's not so obvious in here, but your H here, it's bold face. Your A and your O, they are bold face. Okay? So we use them. We use the first letters, O, H, and A. And then if you remember the Sohcahtoa, then you will immediately know the value of sine theta, cosine theta, and tangent theta if you have a triangle. So sine theta, that's your S, that's equal to opposite over the hypotenuse. So sine theta opposite over the hypotenuse. Ka, this is cosine theta, equals adjacent over hypotenuse. Adjacent over the hypotenuse. That's your cosine theta. And TOA, this is opposite over adjacent. And that's equal to your tangent theta. So tangent theta, opposite over adjacent. Okay? So these three values here, based on this triangle, these three values here, collectively, they are known as Sohcahtoa. Okay? Now, for the other three trigonometric functions that you see in here, we have this guy here, CSC. Okay? CSC, it means cosecant. Cosecant of theta. So CSC. cosecant of theta. And the value of cosecant theta is 1 over sine theta. Okay? So it's the reciprocal of your sine theta. That's cosecant theta. And using these three guys here, or just the two guys here, opposite and hypotenuse, cosecant theta is hypotenuse over opposite. So you just get the reciprocal of this guy here. Okay? And then for this, sec theta, this is secant of theta. So secant of theta, that's sec theta. This is defined to be 1 over cosine theta. So it's the reciprocal of your cosine theta. Okay? And using, again, the names here, hypotenuse and adjacent, to be more particular, secant of theta, it's hypotenuse over the adjacent. So reciprocal of your cosine theta. And then finally, you have your cotangent theta. So this guy here, cot theta, it's cotangent of theta. And this guy here is defined to be the reciprocal of tangent. So that's your 1 over tangent. Okay? And the value of cotangent theta, using again these names, it's adjacent over the opposite. Okay? So these are 6 trigonometric functions which we define using triangles. Okay? These functions here, sine, cosine, tangent, cosecant, secant, and cotangent, they can also be defined using another objects in mathematics, particularly circles. Right? So they are defined independently, but they will mean the same thing. Okay? They will mean the same thing as in this guy here. But since in our course, we'll only be dealing with right triangles and not other parts of trigonometry, okay, we'll define the 6 trigonometric functions in terms of these parts here. Okay? And therefore, if we have a right triangle, okay, we might ask you, or I might ask you, to find the values of the 6 trigonometric functions if a theta is given and another side is given, or if two sides are given and then you have to find the value of some theta, etc. Okay? Or I might ask you to find the other sides. Given two sides, what is the length of the other side? Okay? Given this hypotenuse and A, what is the value of B? Okay? Or I can ask you combinations with this one and this one. Okay? Now, in some cases, we will be needing calculators. So make sure your calculator is ready. And if you are using some models of Sharp, for example, EL 531, XXG, XT, whatever, make sure that the mode of your calculator or the setup of your calculator is in degree. The angle that we will be using here, the angle, the measure of, or the unit of measurement for our angle, we will use degrees. Okay? So make sure that the setup of your calculators are in degrees or in degrees. Okay? So, any questions? Okay? So let us look at these examples now. So, in here, in the right triangle below, find the value of x and all the trigonometric functions of theta. So this is a right triangle. Okay, well, all the triangles that we will consider here are right triangle anyway. So you have a right triangle and you are given two sides, the length of two legs. Okay, and you are asked to find the value of x, which is this guy. Okay, it's the hypotenuse. So according to our Pythagorean theorem, okay, remember, let me just draw it again here. If this is your A, B, and C, then A squared plus B squared equals C squared. Okay, so in this case, okay, we have 3 squared plus 4 squared. This should be equal to x squared. Okay, or you have your x squared equals 3 squared, that's 9, plus 4 squared, that's 16. So this is equal to 25. And therefore, our x here, this is equal to plus and minus square root of 25. So this is equal to plus and minus 5. Now, since we are talking about length in here, of course, we will only consider positive values. Okay? So the value that we need, so the value x that we require is positive. Okay? The value x that we require is positive 5. So is x equals 5. Okay? So we now have the value for x. So this is equal to 5. So now we are asked to find all trigonometric functions of theta. Okay? So for the trigonometric functions of theta, we have, let us recall that Sohcahtoa. Sohcahtoa. Since this is your theta, this becomes your adjacent. This is your adjacent. This is the opposite. And this is your hypotenuse. Okay? Take note, this is your theta, so this is your adjacent, this is your opposite. And therefore, we want to answer this second part here, all trigonometric functions of theta. We will have sine theta. According to this, it's opposite over the hypotenuse. So this is your opposite. So you have 3. And the value of the hypotenuse, which is already equal to 5, as solved. Sine theta, it's 3 over 5. Cosine theta, according to this, it's adjacent over the hypotenuse. This is your adjacent side. So this is equal to 4. And again, the hypotenuse is equal to 5. So anyway, let me write x equals 5 in here. And then, TOA, that's tangent theta, equals opposite over adjacent. So this is your theta, this is the opposite. So that's 3. And the adjacent, you have here 4. So you have 3 over 4. Okay? Questions so far? And then, for the other 3 trigonometric functions, okay? So if we go back to this, we need the cosecant, secant, and cotangent. And let's just use these definitions here. 1 over sine theta for cosecant, 1 over cosine theta for secant, 1 over tangent theta for cotangent. Okay? So in here, cosecant theta, this is equal to 1 over sine theta. So this is just the reciprocal of this guy here. This is your sine theta. And the reciprocal of 1 over sine theta, it's 5, or sorry, the reciprocal of sine theta, it's 5 over 3. Okay? For secant theta, this is the reciprocal of cosine theta. So it's 1 over cosine theta. And cosine theta, it's 4 over 5. Therefore, secant theta, it's 5 over 4. And finally, you have the cotangent theta. This is 1 over tangent theta. The reciprocal of tangent theta is 1 over tangent theta. And according to this, the reciprocal of tangent theta will be 4 over 3. Okay? So these are the 6 values of the trigonometric functions of theta. Okay? Take note, we are not asked to find the value of theta. We are asked to find the trigonometric functions of theta, or the values of the trigonometric functions of theta. Okay? Questions? Next. So same, we are asked to find the value of x and all the trigonometric functions of theta. So these are the two legs, 5 and x. And according to the Pythagorean theorem, we should have 5 squared plus x squared. And this should be equal to the square of the hypotenuse. And the hypotenuse here is 13. So this is equal to 13 squared. So if we solve for x, we have x squared here equals 13 squared. Calculate that it is equal to 169. And of course, your 5 squared, you put it on the other side. So we'll have minus, and 5 squared, that's 25. Or you have x squared equals 144. Okay? And if we take the square root of this, we'll just give here the positive value of x, because anyway, we will be talking about length. So if we take the square root of this and the positive value, we will just get 12. So the value of x in here, this is equal to 12. Okay? For the trigonometric functions of theta, so we will have here sine theta. Oops. Sine theta again, it's so. So opposite, which is 5, over the hypotenuse, which is 13. So 5 over 13. Cosine theta. So ka, that becomes adjacent here, it's 12. And then the hypotenuse is again 13. Okay? And then we have the tangent theta. So TOA. So you have here 5. This is the opposite. And then the adjacent, which is equal to 12. So again, if you still need this, let us write it. So Sohcahtoa. So this is the H here. This is the adjacent side. And this is the opposite side. Okay? And then for the other three functions, we have cosecant theta. This is 1 over sine theta. So the reciprocal is 13 over 5. That's for the cosecant of theta. For the secant of theta, this is equal to 1 over cosine of theta. And the reciprocal of cosine theta, here it's 13 over 12. And then for tangent theta, we have the cotangent. Okay, the reciprocal of 1 over tangent. So cotangent theta, it's the reciprocal of tangent. And the reciprocal of tangent theta, this is equal to 12 over 5. And these are the 6 values for the trigonometric functions of theta with this configuration. Okay? Questions? Next problem. So in the right triangle below, find the value of x and all the trigonometric functions. So in here, this is the value of x. It's one of the legs. This is 3, the other leg. And of course, this is the hypotenuse. So again, for the value of x, this is 3 squared plus the other leg here. So we have x squared. This is equal to 3 square root of 5 quantity squared. Okay? So 3 square root of 5, that's your hypotenuse in here. So if we solve for x, first let's have that x squared, and that's equal to this guy here, 3 square root of 5 squared, that becomes 9 times 5. And then minus, because this guy, we will bring it to the other side. And 3 squared, that's equal to 9. Or we have here 9 times 5, that's 45, minus 9. And 45 minus 9, this is equal to 36. Okay? And therefore, our x, this is equal to square root of 36. Again, we take the positive value. So x equals 6. So the value of this x here is equal to 6. Okay? Now, we want to find all the values of trigonometric functions of theta. This is your theta. So this is the angle. Okay? This is your theta. If this is your theta, the one opposite to it is this leg. So this is your opposite. And then this is your theta. So this is the one adjacent to theta. So this is your adjacent. And of course, this is still your hypotenuse. Okay? Therefore, we look at the 6 values. Let's start with sine. Sine, it's opposite. Opposite, it's 3. Okay? Divided by the hypotenuse. The hypotenuse, it's 3 square root of 5. So if we simplify this is 1 over square root of 5. And if we rationalize this is square root of 5 over 5. Okay? For cosine theta, ka, that's adjacent over the hypotenuse. Adjacent side, we solved it as 6. The hypotenuse, it's still 3 square root of 5. If we simplify this is 2 over square root of 5. If we rationalize this is 2 square root of 5 over 5. Okay? And then tangent theta. Tangent theta, it's TOA. So it will be opposite over the adjacent. So we will have 3. That's the opposite side. And the adjacent side, it's 6. So this is equal to 1/2. Okay? For the other 3, let's get the reciprocals. Cosecant theta. This is 1 over sine theta. And 1 over sine theta, the reciprocal of this, or the reciprocal of this. So this guy here, it's square root of 5. Okay? For secant theta, it's the reciprocal of 1 over, or it's the reciprocal of cosine theta. So it's 1 over cosine theta. And the reciprocal of cosine theta, so we can use this or we can just use this. We will get square root of 5 over 2. And finally, for the cotangent of theta, this is the reciprocal of tangent theta. And this is your tangent theta. So if we get the reciprocal, that's equal to 2. So these are the 6 values for the trigonometric functions of theta. Okay? So again, take note the location of theta. Okay? And from that location, you assign the adjacent and the hypotenuse. Okay? So this is your theta. This is that part. Okay? The opposite side will be this. The adjacent side will be this. And if we look at the previous problem, this is your theta. The opposite side is this. The adjacent side is this. Okay? And even if you have something like that, so say you have something like this, and this is your theta, and this is right. So the opposite will be this guy here. So this is your opposite, this is your adjacent, and this is your hypotenuse. Okay? Questions? Okay? Now, we will be talking about some special triangle. Okay? So the first triangle is an isosceles triangle, okay, with this configuration. We have a 45, 45, 90 triangle. By this we mean one of the angles is 45 and another angle is actually 45. So two angles are 45. And of course, since we are talking about right triangle, the the other angle will be 90 degrees. So 45, 45, 90. Okay? And suppose we have this configuration. You have this as 1. You have this as 1 again. That's why it's an isosceles. Okay? Two sides are equal. And therefore, their opposite angles are also equal, or the measure of the opposite angles are equal. And if you look at this, the hypotenuse will be equal to square root of 2. Okay? The hypotenuse will be square root of 2 because 1 squared plus 1 squared, that's 1 plus 1, that's equal to 2. And the hypotenuse will be square root of that. Okay? So if we calculate the trigonometric values of 45 degrees, we will have the following. We can use this or this guy here, it's the same. Sine theta, that's opposite over the hypotenuse. The opposite, okay? So suppose this is, let's take this as our theta. Sine theta, that's opposite over the hypotenuse. This is your opposite. This is the adjacent. This is the hypotenuse. So opposite, it's just 1. The hypotenuse, it's square root of 2, which gives us square root of 2 over 2 if we rationalize this. And you have that guy. For tangent, or for cosine theta, this is adjacent over hypotenuse. But again, adjacent side, it's 1. So you will have 1 over the hypotenuse, it's square root of 2. So this is square root of 2 over 2. And you will get this guy here. Tangent theta, TOA. Opposite over the adjacent, that's just 1 over 1. Okay? So you will have tangent 45 degrees, it's 1. So again here, sine of 45 degrees, it's square root of 2 over 2. Cosine of 45 degrees, again, square root of 2 over 2. For the secant, okay, secant, it's the reciprocal of cosine theta. The reciprocal of cosine theta here. And if we use this guy, the reciprocal will just be square root of 2. So secant theta, it's square root of 2. Cosecant theta, same. It's the reciprocal of sine theta, and that's square root of 2. And cotangent, it's the reciprocal of tangent. So if we get the reciprocal, it's still 1. So secant 45 degrees, that's square root of 2. Cosecant of 45 degrees, that's square root of 2. Cotangent of 45 degrees, that's equal to 1. Okay? So this is the 45, 45, 90 triangle. So you need to remember these values. For the next special triangle, we have the 30, 60, 90 triangle. 30 degrees, 60 degrees, 90 degrees. So if you look at this, we have here 30 degrees, here we have 60 degrees. And of course, this is still your 90 degrees. Now, if we set the length of the leg opposite to 30 degrees to be 1, then the adjacent will be square root of 3. Okay? Adjacent of the 30-degree angle. Okay? The hypotenuse will be equal to 2. 1 squared plus square root of 3 squared. Square root of 3 squared, that's 3. So 1 plus 3, that's 4. We get the square root, we get 2. Okay? So, look at this. Let us look at these tables and just look at 30 degrees. So, this is our theta in here. So, if we look at that, our sine theta, this becomes our opposite. That's your 1. So, you have 1 over. This is the hypotenuse, and that's 2. So, we have this 1/2. Sine 30 degrees, that's 1/2. If we look at cosine, sorry, let me put the exact value here. So I'm using 30 degrees in here, 30 degrees in here. Now, cosine 30 degrees, that's your theta. That's your adjacent, which is square root of 3 over the hypotenuse, which is equal to 2. That's why you see here square root of 3 over 2 for cosine theta, 30 degrees. For tangent theta, it's TOA. So we have tangent 30 degrees, tangent 30 degrees. So opposite, which is 1, over the adjacent, which is square root of 3. And this is equal to square root of 3 over 3 if we rationalize this. So you see this guy here. Okay? If now we chose this as our theta, so let's try. We now at 60 degrees here. So we want to find 60 degrees or sine of 60 degrees. This is your angle theta. This becomes the opposite. This becomes the adjacent because this is the angle. And the opposite, this is your 60 degrees. This is the opposite side, which is square root of 3 divided by the hypotenuse, that's still 2. So you see that square root of 3 over 2. Cosine 60 degrees. Cosine, it's ka. This is the angle, this is the adjacent side. So you will have 1 over the hypotenuse, which is equal to 2. So cosine 60 degrees, it's 1/2. And finally, tangent 60 degrees. Okay? Tangent 60 degrees, TOA. So this is the opposite. That's square root of 3. And the adjacent, it's equal to 1. So square root of 3 over 1. That's why you see this square root of 3 here. Okay? And for the reciprocals of this, you have your secant theta for 1 over cosine theta, cosecant theta for 1 over sine theta, cotangent theta for 1 over tangent theta. Okay? And you get the reciprocals, you will get these answers. Okay? So take note, 30 degrees here, 30 degrees here, 60 degrees here, 60 degrees here. Okay? Let's look at this first set of examples. We want to find sine squared 60 degrees plus cosine squared 60 degrees. Now, you can write the actual values of your sine 60 degrees, and then you square it. And then, of course, cosine 60 degrees, and you square it, and then you add them. Okay? By the way, this symbol here, this means you want the square of 60 degrees. So you have to get the value of 60 degrees, and then you square it. Same is true with the other addend. You get your cosine 60 degrees, and then you square it. Okay? One way to solve this, is to get the actual values of sine 60 degrees and cosine 60 degrees. Okay? So if we look at this, sine 60 degrees, it's square root of 3 over 2. Cosine 60 degrees, it's 1/2. Okay? So we have sine squared 60 degrees plus cosine squared 60 degrees. This is equal to square root of 3 over 2 quantity squared plus 1 over 2 quantity squared. And this is equal to 3 over 4 plus 1 over 4. And this is equal to 1. Okay? That's one way to solve this guy here. Now, another way to solve that guy is through Pythagorean Theorem. Okay? So here, we have for any theta, okay? For any theta, you have sine squared theta, okay, plus cosine squared theta. This is equal to 1. Whatever your angle is, okay, whatever your real number is or your angle is, square of sine of that plus square of cosine of that, it's always equal to 1. Okay? So in this case, you have 60 degrees here, 60 degrees also here. If you do this, this is equal to 1. Okay? Keep in mind, of course, if they have different angles or different numbers, it's not equal to 1. Possibly not equal to 1. In fact, most of the time, not equal to 1. Okay? So take note of this. If you have the same angle here, sine squared 60 degrees plus cosine squared 60 degrees, it's equal to 1. Or for any angle theta, sine squared theta plus cosine squared theta, that's equal to 1. Okay? So that's the other solution. Let's look at number 2. You have here sine 45 degrees, cosine 30 degrees, cotangent 60 degrees. So you are just multiplying these numbers. Sine 45 degrees. Let's look at our table here. 45 degrees. This is the 45 degrees. Sine of that 45 degrees, it's a square root of 2 over 2. So you have here square root of 2 over 2. Cosine 30 degrees. This is cosine. This is 30 degrees. So cosine of 30 degrees, it's a square root of 3 over 2. So we have square root of 3 over 2. Cotangent 60 degrees. Cotangent 60 degrees. This is your cotangent. This is your 60 degrees. So cotangent of 60 degrees, it's a square root of 3 over 3. Square root of 3 over 3. Okay? So, if we simplify this, we will get what? Square root of 3 times square root of 3, that's just 3. And then you have your square root of 2 here, over 2 times 2, that's 4. And then we have the times 3 here. I'll just leave that there because we can cancel the 3. Okay? So this guy here cancels with this. And therefore, the final answer will just be square root of 2 over 4. Okay? Questions? Number 3, we have tangent 30 degrees times cosine 60 degrees minus secant 60 degrees. For tangent 60 degrees, this is tangent 30 degrees. Tangent 30 degrees here. We have tangent, and then this is your 30 degrees. This is the square root of 3 over 3. So square root of 3 over 3. We have here cosine 60 degrees. Let's just use this. We got cosine 60, that's 1/2. So times 1/2 minus secant 60 degrees. It's the reciprocal of cosine 60 degrees. So we get the reciprocal of 1/2. That's just 2. Okay? So if we simplify this, you have square root of 3 over 3 times 1/2 minus 4 over 2. That's equal to 2 here. 4 over 2, that's equal to 2. So we will get square root of 3 over 3 times negative 3 over 2. 1 minus 4, that's negative 3. And therefore, we can cancel out the 3 and the 3 here and get negative square root of 3 over 2 as the final answer. Okay? For number 4, we have cosecant 45 degrees times cotangent 45 degrees plus cosine 30 degrees. Cosecant 45 degrees, it's the reciprocal of sine 45 degrees. Sine 45 degrees, according to this, it's square root of 2 over 2. So if you get the reciprocal, it's just square root of 2. And even if we look at our table here, cosecant 45 degrees, that's just square root of 2. So in here, we have square root of 2 times cotangent 45 degrees. Try to check. This is just 1. And cosine 30 degrees, we have the cosine 30 degrees here. It's square root of 3 over 2. So plus square root of 3 over 2. Okay? So we can write the final answer that way because anyway, we cannot simplify it even if we try to write them as a single fraction. So we can write the final answer this way. Okay? Questions? Okay. Next example here. Now, using a calculator, find the value of x. So this is our x. Round off the final answer to 2 decimal places. So in here, we are given one angle, the value of the opposite side of the given angle, and then we are asked to find the length of the adjacent side. Okay? Now, look at this. You have the angle, you have the opposite side, and you have the adjacent side. So you have the opposite and the adjacent. We can use tangent of the given angle. Remember? Sohcahtoa. You have this, you have, oops, I forgot the H there in the ka. So you have here ka and then toa. So you got the toa, you got ka, and you got so here. But in here we have the angle, we have the opposite side, and we have the adjacent side. So we can use toa. And according to this, we now have tangent 33 degrees. This is equal to, so this is your 33 degrees. The opposite side is 5. And the adjacent side is x. Which means x is equal to 5 over tangent 33 degrees. Okay? So let us use our calculator to find tangent 33 degrees. Again, make sure that your calculator is in degree mode. So if we compute for tangent 33 degrees, okay, we'll get 0.649407593. Okay? And of course, the numerator, it's 5. So tangent 33 degrees, you have this number here. And then we do the division now. 5 divided by that this guy here. So 5 divided by that number, we have 7.6993 dot dot dot, but we want to round off to 2 decimal places, so this becomes 7.70. So this is the value of x. Okay? Question for this slide. So again, using a calculator, we want to find the value of x, and we want to round off the final answer to 2 decimal places. So in here, you have 25 degrees, and this is the angle. You have the opposite side, and you have the adjacent side. Right? This is the adjacent. This is the opposite. So again, you have the adjacent and you have the opposite. It's helpful to use the tangent. Okay? So you will have tangent 25 degrees. This is equal to the opposite, which is x, and then the adjacent, which is 7. Or that your x is equal to 7 times tangent 25 degrees. So if we calculate this, okay, you have your tangent 25 degrees. So this is 7 times 0.466307658. And if you multiply this by 7, we will get 3.2641, etc. Or up to 2 decimal places, you have 3.26. Okay? Okay? Now, there is a question here. Suppose you got 7.6559. So when we round up, it will be, so in here, suppose you got 7.655. You don't even have to write that 9 here. But anyway, if we round this off, since this is 5, this will increase. Therefore, this is 7.66. Okay? Other questions? Next problem here, using a calculator, find the value of x. And then, in addition, I want to find, let us find all trigonometric functions of this given angle here. Okay? So, you have, for the first, you are given the adjacent side, and you are also given the hypotenuse. So if we look at if we look at our Sohcahtoa, this is the angle. We are given the adjacent and the hypotenuse. The best to use is cosine. Okay? Therefore, we have cosine of the given angle. What is the cosine of the given angle? Cosine 50 degrees. This is equal to adjacent, which is 4, and then the hypotenuse, which is x. Okay? Or your x, this is equal to 4 divided by cosine 50 degrees. So if we calculate cosine 50 degrees, we will have 0.64278761. And then the numerator is still 4. Okay. Therefore, we have 4 divided by that number on the denominator will give us 6.22285 blah blah. And of course, 2 decimal places, this is just 6.22. Okay? So this guy here is 6.22. Okay? Now, we want to find the values of all trigonometric functions of these 50 degrees. So we have the value of 4. We got the value of hypotenuse, approximate value. Okay? We can get the approximate value of this side here. Okay? So this side here will be what? Say, let this be y. Okay? Y squared plus 4 squared. This is equal to your x squared. And you know the value of x already. Let's just use 6.22. Of course, we will have a lot of rounding errors here. But anyway, let's use 6.22 for our x. And then if we square that, 6.22, if we square that, we will get 38.6884. 38.6884. Let's retain this. And then you have your y squared in here. And then this 4 squared, we put it on the other side. So we will have minus 16. So this guy minus 16 will get 22.6884, which means our y, we take the square root of this, we'll get 4.76. So approximately 4.76. So this guy here, it's approximately 4.76. 0.76. Okay? Questions? So, we have the value of the opposite side. We can solve for the SO, we can solve for the TOA, and of course, we can have the cosine of 50 degrees. We just need to replace this with x equals 6.22. Okay? So let us adjust these guys here. Okay. So first, cosine 50 degrees. Cosine 50 degrees. This is your 4 over x, that's 6.22. Let's just write it as this guy here. Anyway, let's use 6.22. So approximately cosine 50 degrees, it's 6.22. This is equal to, or approximately equal to, so 4 divided by 6.22. This is approximately equal to 0.6431. According to this. According to this calculation, it's approximately equal to 0.6431. Okay? Using calculator, we have solved it. Look at this, 0.64278. And look at that rounding error. Okay? Look at that rounding error. Using calculator, cosine 50 degrees, this is this guy here. 0.64278, Okay? So you see what I mean when you do the rounding in every intermediate values. For example, you round off here, you will get plenty of rounding error. Okay? In here, we use 6.22 instead of the longer version. Okay? And upon using 6.22, we get 0.6431. But the actual value, it's 0.64278, There's a 1 at the end. But the point is, it's a big rounding error. Okay? Looks small, but in the sense of real number, this is still big. But at least this guy here and this guy here is close up to 2 decimal places. Okay? How about for the sine? Sine 50 degrees. According to this, now we have opposite over the hypotenuse. So according to this, you have 4.76 divided by 6.22. So if we do this division, so 4.76 divided by 6.22, it's 0.765273. 312. Let's say 312. Okay? using calculator. Sine 50 degrees. We use calculator. Sine 50 degrees. This is 0.76604443. So look at that. 7652, here 7660. It's a big rounding error, but at least they are close, or they are the same up to 2 decimal places. Okay? So I want you to compare the rest, the other trigonometric functions: tangent theta, cosecant theta, cotangent theta, and yeah, those four, the remaining four. So tangent, cosecant, cotangent, and secant. Try to use the values that we have here and use your calculator to calculate, to find the actual values and compare the rounding errors. Okay? Questions? Next problem here. If a 4.5 meter ladder makes an angle of 63 degrees with the ground, then how high up the wall does it reach? So suppose this is the ground and this is the wall. Okay? And let us consider the ladder here. Okay? So suppose this is your ladder. Okay? And according to this, it's a 4.5 meter ladder. So the length of this guy here, it's 4.5. The angle with the ground in here, it's 63 degrees. And we are asked this guy here. Let us label that as X. Okay? So this is the situation. So now let X be the height, be the height as shown on the left, as shown on the left. Okay. Then we have the angle here, we have the opposite side, and we have the hypotenuse. Okay. Opposite, hypotenuse, we have sine 63 degrees. This is equal to opposite, which is X, over the hypotenuse, which is 4.5. Or your X is equal to 4.5 times 63 degrees, or sine 63 degrees. And let us calculate this. 63 degrees, we get the sine of that. Okay? And then we multiply this by 4.5. we will get 4.0095 29 29359. Okay? Or this is, since we have one decimal place for this guy here, let's just put one decimal place in here. So this is approximately equal to 4.0 meters. So the height here, it's 4 meters. Questions? Next problem here. What is the height of a tree if it casts a 12-meter shadow to the ground when the angle of elevation of the sun is 29 degrees? Let us look at the situation. So suppose this is the ground and you have the tree in here. Okay? And it casts a shadow, a 12-meter shadow. So the length of the shadow is 12 meters. Okay? So suppose the sun here, okay? The sun is somewhere here. The sun is somewhere here. It's not visible. Let's use a darker. Okay? And then, of course, 12-meter shadow. And the angle of elevation is 29 degrees. So according to this, the angle of elevation is 29 degrees. Meaning if you are at this particular point, okay, the angle that you have in here is 29 degrees. Okay? So the triangle that we have in here is the following. So you have this, and then you have this. And of course, you have this part here. So the shadow is at this particular, this is the 12-meter shadow. So this is the 12 meters. So we want to find the height of the tree. Okay? So let's solve this. Let h be the height of the tree, be the height of the tree. So you have the height of the tree here. It's the one we want to know. And you have the shadow, which is 12 meters. Adjacent side, it's the 12 meters. Opposite side, it's your h. Take note that this is the angle of elevation. Okay, that's 29 degrees. Okay, you are given the height, which is the adjacent. The 12 meters, which is the adjacent, and you are asked to find the height, which is the opposite side. So opposite and adjacent are given. So we can use tangent. Then we have tangent 29 degrees, Toa. So this is opposite, which is h, divided by the adjacent, which is equal to 12. So we have h equals 12 times tangent 29 degrees. And if we solve for this, let's see. So 12 times tangent of 29 degrees. This is about 6.6517. Let's use two decimal places. So we have 6.65. So this is in meters. So 6.65 meters. That is the height of the tree in here. Okay? Questions? This will be the last problem for this lecture. From a point 25 meters from a building, the angle of elevation to the fifth floor is 26 degrees, and the angle of elevation to the top of the building is 67 degrees. What is the distance between the fifth floor and the top of the building? Let's illustrate this. Suppose this is the ground, and let us put the building somewhere here. So again, from a point 25 meters from a building, the angle of elevation to the fifth floor is 26 degrees. And the angle of elevation to the top of the building is 67 degrees. So suppose this is the point 25 meters away from the building. Okay? 25 meters away from the building. Let us adjust this. I think let me put it here. And then, suppose this is your fifth floor. Okay? This is the fifth floor, height of fifth floor. So according to the problem, the angle of elevation in here, it's 26 degrees. So here you have 26 degrees. And then the angle of elevation from this same point to the top of the building, okay? Let me use this guy here. This is the top of the building. According to this, the angle of elevation is 67 degrees. So from this up to this is 67 degrees. Okay? So we are asked to find the height or the distance between the fifth floor and the top floor. Let us label this as D. Okay? So, we have two right triangles in here. The first right triangle is this with the blue hypotenuse, and this guy here, and this length here, which is 25 meters. So from this point up to this point, this is 25 meters. Okay? So this, and this, that's a right triangle. The other right triangle is the one with the hypotenuse with color black. So this guy here, all the way down to the ground floor, and of course this 25 meters here. Okay? So let us translate this first to triangles only. So we have the following. We have this, and then this guy here. Let me remove this part. And then you have another one, something like this. So let me color that blue. Okay? So two right triangles, the black and then the blue part here. And we want to find this D here. So we want to find this corresponding value here. This is the D. We know that this is equal to 25. Okay? 25 meters. We are given this angle here. We are also given this angle here. So, using right triangle, since that's the only tool that we have, we use right triangle to find this D. So what we're going to do is first to find the total height of the building. Okay? And then, second thing that we need to do is to find the height of the fifth floor from the ground. And once we know those two guys, we can now get the value of D. Okay? So let's do that. Let H or let D be the distance between the fifth floor and the top of the building. Fifth floor and the top of the building. Top of the building. Okay? On one hand, the top or the height of the fifth floor, the height of the fifth floor from the ground is so you want to find this. This is the opposite of 26 degrees, and you are given the adjacent side. Okay? So opposite, adjacent, TOA, tangent of 26 degrees equals the opposite side over the adjacent side. So the height of the fifth floor is 25 tangent of 26 degrees. Okay? So if you just look at this, again, how did we get this guy? Let's just draw it here again. So 26 degrees, this is equal to 25. And say, let's put this as h sub 5 or just h. Anyway, I did not use any h in here. So tangent 26 degrees, this is equal to opposite, which is h, over the adjacent, which is 25. That's why you have 25 times tangent 26 degrees as your h. Okay? So let us approximate this. (25) times tangent 26. This is roughly 12.1933. Okay? On the other hand, the height of the building, from the ground is similar situation. This time you have 67 degrees as the angle. So this is 25 times tangent 67 degrees. Correct? So this is 67. This is the total height. So that's the opposite side. And you still have 25 degrees. So you have this. So 25 times tangent 67. This is roughly 58.8963. Therefore, the D is just the total height minus the height of the fifth floor. Therefore, the distance between the fifth floor and the top of the building is the difference. Okay? Is approximately this 58.8963 minus 12.1933. So approximately, let me just write it here. 58.8963 minus 12.1933, which is equal to, so 58.8963 minus 12.1933. 46. Yeah, 46.7073.
Yeah.
So let's just write that. So this is in meters. And that's the final answer.